Here is a problem from dynamics, and what is asked is that if this system where you have 5 kg on one side and 2 kg on the either side and pivoted at the center of a rod, a light rod of length 1 meter, if this system you have to hold this by hand in order to balance, otherwise obviously the 5 kg will, when you leave this, when you just release it, it would rotate clockwise, and that is exactly what is asked. When you just release the system, what is the initial angular acceleration? You know that it is going to rotate clockwise. What is the initial angular acceleration? Okay, so for this entire thing can be considered as if rotating about, when you just release it, rotating about this point O. Let's fix this O, and you can imagine an axis passing through O and perpendicular to the paper. So sigma moment about O, or sigma torque about O, has to be I alpha. This is from the rotational mechanics. Okay, so this, the left side is the summation of the moments acting about O, and the right side is the inertia, the rotational inertia basically, where I is the mass moment of inertia of the entire thing about O, and alpha is the angular acceleration which is asked. So there are two things we need to find out: sigma moment about O. So in a minute we'll come here, but first let's see what is the moment about O. The moment about O is, can be found out from the free body diagram. Let me draw a free body diagram with all the forces on the light rod. At O you have the hinge reactions OX and OY. Okay, it's a hinge pivoted, and this is mg, weight acting 5 kg, so mass into g, which is 5 into g. G is 9.8. It's not given as 10, so you have to take it as 9. And on the left side the weight is acting towards down, so it's 2g, and the moment arm is all 0.5 because it's pivoted at the center, so this is also 0.5. Okay, so what is the net movement about O? OX and OY don't take part in the movement because they are passing to the same point, so 5g into 0.5 is the clockwise movement, the right side thing, and the left side thing produces anti-clockwise movement, so minus 2g into 0.5. The moment are mean same, so this becomes 3g into 0.5g, which is 1.5 into g. So this is the moment, okay, which is acting towards right. Okay, now let's find out I. Now I, what is I? If you know the meaning of I, you can easily solve this problem. I is the mass moment of inertia. So if you have a mass, and okay, so the mass moment of inertia of this, how it is mathematically defined is, if you have an axis and this mass is, entire mass is concentrated at a distance r, and this mass is m, so the mass moment of inertia of this mass about this axis will be m r square, because the entire mass is concentrated at r. Similarly, you have three components here: the rod, the entire thing is moving, remember, rod and the 5 kg mass, okay, let me write 5m, and the 2 kg mass, which is 2m. Okay, the I rod is basically light, it doesn't have any mass, and you know that mass moment of inertia is something which is m into r square, so it is basically 0 because it's a light rod. You don't need to do any work in order to rotate it. That's what it means. The 5 kg is entire 5 kg is concentrated at a distance r. The entire 5 kg, it's a point mass which is concentrated at a distance r. So it's basically m1 r square, where r is 0.5, plus the entire 2 kg is also concentrated at the same distance r square. So it is m1 r square plus m2 r square, 5 into r, which is 0.5 whole square, plus 2 into, this is an easy problem if you understand the basics. There's nothing to break down your head here. So what we get here is 7 into 0.5 whole square, which is 1.75. Remember the units, it's kg meters square. So once I get I, so I use this rotational mechanics equation alpha. So alpha is sigma m naught by I, and sigma m naught is 1.5 1.5 into 9.81 by I, which is 1.75. So 1.5 into 9.8. So once you calculate this, you get something called 8.4 radians per second square. That is the unit of angular acceleration. So the answer is 8.4 radians per second square. The only thing in this problem is you need to know what is the meaning of rotate, the Newton's law in rotational amplified. I mean, the other way of stating Newton's law in rotational is sigma m naught is equal to I alpha. Okay, this is a synonym of what you have in translation, that is sigma f is equal to me. Same thing when you look in the rotational aspect, it is sigma m naught is equal to I alpha. So you need to know how to calculate sigma m naught and I, mass moment of inertia. So this is the approach. Thank you.